In this video, we will discuss simplifying irrational expressions. The square root of a variable is best understood by using the rational exponent notation and the laws of exponents. We consider only real numbers and assume that the variables represent positive values. The square root of x squared is the same as x squared to the 1/2 power, which is x to the 2 times 1/2, which is 1. So x to the first, which is x. The square root of x to the fourth is x to the fourth to the 1/2 power, which is x squared. The square root of x to the sixth is x to the sixth to the 1/2 power, which is x cubed. A positive variable with an even number exponent is a perfect square. To find the square root of a variable factor, take half of the exponent. Find the square root of the positive variables. The square root of x to the 8th is x to the 8th to the 1/2, which is x to the 4th. Negative square root of x to the 12th is negative x to the 12th to the 1/2, which is negative x to the 6th. Plus or minus the square root of x to the 18th is plus or minus x to the 18th to the 1/2, which is plus or minus x to the 9th. The square root of a squared over b to the 4th is a squared over b to the 4th to the 1/2 power, which is a squared to the 1/2 divided by b to the 4th to the 1/2, which is a to the first over b squared, or a over b squared. There are two square roots for a positive radicand. It is customary to indicate whether the positive or principal square root, the negative square root, or both square roots are to be considered by putting the appropriate sign in front of the radicand or its coefficient. The square root of 4 is 2. Negative square root of 4 is negative 2, and plus or minus square root of 4 is plus or minus 2. To simplify radicals using rational exponents and the laws of exponents, first convert the radicals to equivalent expressions using rational exponents. Then apply the laws of exponents and the arithmetic of fractions. Convert simplified expressions back to radical notation if desired. So here we will convert the radical expressions to equivalent expressions using rational exponents and simplify if appropriate. The cube root of x is x to the 1/3. The fifth root of 2y is 2y to the 1/5, or 2 to the 1/5, y to the 1/5. The cube of the square root of AB is AB to the 1/2 all cubed, or AB to the 3/2. We could also write that as A to the 3/2 times B to the 3/2. The fourth root of 16b to the 8th is 16b to the 8th to the 1/4, which is 16 to the 1/4 times b to the 8th to the 1/4. And we can take the fourth root of both of those to get 2b squared. The cube root of 27xy to the 5th is 27xy to the 5th to the 1/3 to the 4th, or 27 to the 1/3, x to the 1/3, y to the 5th to the 1/3 to the 4th. So that's 3x to the 1/4, y to the 5/3, all to the 4th, which is 3 to the 4th, x to the 1/3 to the 4th, y to the 5/3 to the 4th, which is 81, x to the 4/3, y to the 20/3. When coefficients of variable terms have rational exponents, the numerical equivalent can be determined. Usually, if the coefficient is a perfect power of the indicated root, we will evaluate the coefficient. Otherwise, we may leave the coefficient with the rational exponent. 8 to the 2/3 equals 8 to the 1/3 squared, which is 2 squared, which is 4. But 5 to the 2/3 does not simplify. Perform the following operations and simplify. Express answers with positive exponents in lowest terms. X to the 3/2 times x to the 1/2 is x to the 3/2 plus 1/2, which is x to the 4/2, or x squared. 3a to the 1/2 b cubed all squared is 3 squared times a to the 1/2 squared, times b cubed squared, which is 9 times a to the 1/2 times 2 times b to the 3 times 2, which is 9ab to the 6th. X to the 1/2 over x to the 1/3 is x to the 1/2 minus 1/3, which is x to the 1/6. 10a cubed over 2a to the 1/2 is 5a to the 3 minus 1/2, or 5a to the 5/2. Evaluate the expressions from the previous example, parts A and D, for x equals 2 and a equals 3. We just plug in 2 for x in both of these expressions, but we know that this whole thing, x to the 3/2 times x to the 1/2, is x squared, so that's 2 squared, which is 4. I made some mistakes in entering this second one, and I apologize for that. We determined back here that this whole thing is equal to 5a to the 5/2. So 5a to the 5/2 is 5 times 3 to the 5/2, which is about 77.94228634. It's generally worth the effort to simplify an expression before evaluating. Long sequences of calculator steps are tedious to enter, and it's easy to make a mistake. If you simplify first, you will have far fewer steps to enter and are more likely to find the correct answer. Perform the operations and express the answers with positive exponents. A to the 2.3 times a to the 3 is a to the 2.3 plus 3, which is a to the 5.3. 5 times a to the 3.5 times b to the 0.5 all squared is 5 squared times a to the 3.5 times 2 times b to the 0.5 times 2, which is 25a to the 7th b. To factor an algebraic expression is to write it as the indicated product of two or more factors, that is, as multiplication. To simplify square root radicals containing perfect square factors. First, if the radicand is a perfect square, express it as a square root without the radical sign. If the radicand is not a perfect square, factor the radicand so that one factor is the largest possible perfect square factor. The square roots of the perfect square factors are written outside the radicand and outside the radical, and the other factors stay inside under the radical sign. If the radicand is not a perfect square and cannot be factored into one or more perfect square factors, it is in simplest radical form. Simplify the radicals. The square root of 32 is the square root of 16 times 2, which is the square root of 16 times the square root of 2, or 4 root 2. Square root of y to the 7th is the square root of y to the 6th times y, which is the square root of y to the 6th times the square root of y, which is y cubed times the square root of y. Square root of 18x to the 5th is the square root of 9 times 2x to the 4th times x, which is the square root of 9 times x to the 4th times the square root of 2x, which is 3x squared times the square root of 2x. Square root of 75 xy cubed z to the 5th is the square root of 25 times 3 times x times y squared times y times z to the 4th times z, which is the square root of 25 y squared z to the 4th times the square root of 3xyz. So that's 5yz squared times the square root of 3xyz. The square root of 7x cannot be simplified.